Hello everyone, welcome to the discussion of asymmetric Aldol reaction. So in previous video we have discussed about the definition of asymmetric synthesis and Aldol reaction. And Aldol reaction can be carried out with the 4 different categories using different substrates. That means there are 4 possibilities of the substrates you can use in Aldol reaction. That is achiral aldehyde and achiral enolate combination, achiral aldehyde chiral enolate combination, chiral aldehyde and achiral enolate combination, chiral aldehyde and chiral enolate combination. So the continuation of the previous video. So let us start the discussion of the first category, that is the combination of achiral aldehydes and achiral enolate in aldol reaction. So let us take an example. Where we are discussing about achiral aldehyde and achiral enolate. So for example, if you take any aldehyde, consider this is an aldehyde which doesn't have any chiral center, so achiral aldehyde, and consider another ketone. Okay, this is one substrate, and these two substrates treat with the base, and you will get a beta hydroxy ketone, which is aldol. So as I mentioned, there are two chiral centers present here. So you may expect 4 different type of stereoisomers here, but whereas you will get syn and anti combination, so one should be major here. That means you are getting unequal ratio of syn and anti, that means diastereoselective reaction. So this asymmetric aldol reaction is a diastereoselective reaction, since you will get 2 unequal ratio of diastereomers. Okay, so before going to discuss about the mechanism of this, let us discuss about each substrate present in this combination, achiral aldehyde and achiral enolate. Let us start with the first substrate, that is achiral aldehyde. Consider this aldehyde. So this aldehyde has sp2 carbon atom. So sp2 carbon atom containing molecules are planar molecules, right? Planar molecule. So consider this molecule as a plane. So plane. So that this is called as a phase. What is phase? It's a planar part of the molecule. So that is called actually phase. So that means there are 2 different type of orientations you can observe here. One is top phase and one more is bottom phase. Okay, so that means the substrate is achiral aldehyde. Since it contains sp2 carbon, it is a planar molecule, so that we can observe 2 different type of phases, that is top phase and bottom phase. So that means any reagent can approach in 2 different orientations, that is from top phase and bottom phase. For example, if you consider this orientation, first we have to give notation for this sp2 carbon center. How to give notation here? So give the notations according to CAP rules. So first one, you see, always viewer can view from the top phase, so give the priority for this. That means oxygen gets highest priority, then alkyl, then hydrogen, so that this is anti-clockwise. That means here top phase you will have C phase. Okay, so this is notation generally psi phase or C phase, and opposite, the opposite one, that is bottom phase. If you look the viewer, if he looks from the bottom phase, exactly you will get opposite from this psi phase, that is called rephase. Suppose if you have substrate like this, suppose if you have substrate like this, and you consider this, so again there are 2 phases you can observe here. One is top phase and one more is bottom face. Again give the notation, there is priorities according to CIP rule. So the top face is V face and the bottom face is psi face. So this is one starting material, that is aldehyde. So aldehyde, how many phases you have? There are two phases, top phase and bottom phase. Consider this. This molecule has a top phase, that is C phase. So you have to call it as, you should not call it as top phase, you have to call it as C phase or psi phase. And if you want to call it as bottom phase, you have to call it re phase. Okay. Now go to another substrate, that is achiral enolate. Since the other substrate is a ketone, so you have to generate enolate. So now treat this one with the base, a strong base. So this abstract the acidic proton, which gives you a carbanion, okay, which is stabilized by counter cation, and this one will undergo enolate form. Okay, this is enolate. Enolate are reactive species, are important species for the formation of CC bonds in organic synthesis. Okay, so this enolate has two different types. You can see this enolate is two different types. One is Z enolate and one more is E enolate. Okay. Consider this Z enolate. So always you have to write a counter cation here. So how we are calling this is Z enolate and E enolate. See, preference is giving like this, 1 and this is a methyl, right? So 1, 2. So this is Z enolate, whereas in this case it is opposite, 1, 2 and 1, 2. So that it is E enolate. So once you get enolate, so there are two forms you can observe, that is Z enolate and E enolate. So this Z enolate formation and E enolate formation is completely depends on the R1. So if your R1 is bulkier, then it prefers always Z enolate, whereas if R1 is smaller, then it prefers E enolate maximum. But in maximum cases, Z enolate is the most preferable one. Okay, so now we have discussed about the starting material, that is aldehyde, and one more is achiral enolate. Let us discuss about Z enolate. Consider Z enolate. So this is Z enolate. There are again two sp2 carbon centers you can observe. See, one is upper sp2 and one more is lower sp2, right? So in this aldol reaction, this lower sp2 is the responsible for the formation of CC bond formation. So that's why always you have to consider this lower sp2 in this enolates. So you have another enolate, that is also E enolate. Right? Now this also has two sp2 carbons, upper sp2 and lower sp2. So I told you, since it is a sp2 carbon containing molecule, so this molecule also a planar molecule. So that means you can observe two different type of phases, one is top phase and one more is bottom phase, right? Consider this only, this sp2 only, okay, this sp2 center, this sp2 center. So give the preferences according to CIP rule. So this top one will get first priority and methyl gets second priority, and this one is third priority. This is very important. So that means if wear is observing from the top phase, okay, top phase, it is anti-clockwise, so that the top phase is called psi phase. Of course the bottom phase is opposite, that is re phase. Whereas in the case of E enolate, there are two phases you can observe. The top phase is 1, 2, 3 again. You can also get here same psi phase and bottom phase is V phase. So overall you have observed that your two starting materials aldehyde and enolates are having different kind of phases, right? So let us discuss about that. You see, aldehyde and enolate, this is the combination, that means achiral aldehyde and achiral enolate. So this achiral aldehyde has two phases, top phase and bottom phase. Okay, top phase is C phase and bottom phase is B phase. So always this achiral enolate is approaching onto this aldehyde, so that this enolate also has two different type of enolates, that is Z and E. So in Z enolate, this is having psi phase and V phase, as well as this E also has psi phase and V phase. That means this aldehyde can approach with the two different type of enolates, that is Z enolate and E enolate. So how many possibilities you can get here? You can see there are different kind of possibilities you can get the approach of this enolates during the mechanism. Consider this enolates. Okay, first one, the aldehyde rephase of this aldehyde, that means enolate rephase of enolate can approach to this rephase of aldehyde, okay, or rephase of aldehyde, that is which can approach by the C phase of enolate. This is Z and this is also Z. We are considering Z enolates only. And then psi phase of aldehyde can be approached by the rephase of enolate, and the psi phase of aldehyde can be approached by psi phase of Z enolate, right? So this is called like combination. This is called like combination, and this is like and this is unlike. So like unlike combination, like unlike. So whatever unlike or like combination, you can call anything, and then like and like combination. So like combination. So there are four possibilities you can observe here with the aldehyde and Z enolate. Okay, aldehyde has two phases, one is rephase and C phase. So this rephase can approach by the rephase of Z enolate. Rephase of aldehyde can be approached by the C phase of Z enolate, and C phase of the aldehyde can be approached by the rephase of Z enolate, and C phase of the aldehyde can be approached by C phase of Z enolate. Okay, consider another possibilities. Take aldehyde again and consider E enolate. Again, this aldehyde rephase can be approached by the E enolate of rephase, and rephase of aldehyde can be approached by psi phase of enolate, and psi phase of aldehyde can be approached by rephase of enolate, and psi phase of aldehyde can be approached by psi phase of enolate. So this is like combination, and unlike combination, unlike combination, unlike combination. So how many possibilities you have so far? So you have totally 8 combinations we have. So let us discuss about one like combination and one more unlike combination of both aldehyde and Z enolate and aldehyde and E enolate. So consider this re combination and C recombination, that means which is unlike combination and like combination. Okay. Start with the achiral aldehyde, that means first case achiral aldehyde psi phase with approachment of achiral enolate rephase. Okay, so this is the first combination we are going to discuss. A simple thing. See, you have aldehyde and you are treating with the Z enolate. See, this is Z enolate. We are discussing about Z enolate. Okay. So now we have to discuss about the mechanism involved in this reaction. See, consider now. So there are two phases here, top phase and bottom phase. So as you know, the top phase is up. According to CAP rules, the priority of this oxygen gets 1, and then alkyl will get second one, and this one third. So it is anti-clockwise. So top phase is C phase and bottom phase is V phase. Whereas this bottom sp2 is the responsible for this CC bond formation. So that means this has two phases here, top phase and bottom phase. And top phase 1, 2, 3, So top phase is C phase and bottom phase is pre phase. So that means what combination we are discussing here? Achiral aldehyde C phase and achiral enolate re phase. So that means aldehyde is top phase and enolate is re phase. So enolate is approaching to aldehyde from the bottom phase. Okay, re phase of enolate is approaching to psi phase of aldehyde. That is what we are discussing. So now what happens? This enolate is approaching to this achiral aldehyde from the re phase. That means it is approaching from bottom phase. Okay, re phase of this enolate is approaching on the top phase of the aldehyde. Okay, now what is happening here? See, you can observe here 1, 2, 3, and this carbon is 4 and 5. And one more thing, this oxygen will get minus charge and this oxygen already having minus charge. So this can be stabilized by a sixth one, that is metal. Okay, they undergo chelation with the metal so that it gets a chair conformation transition state. Okay, so this reaction gives you a stable, a six-membered cyclic chair conformation, transition state. That is called actually Zimmermann Traxler transition state. Okay, so I told you there are totally six-membered chair conformation, right? Okay, now see first one, this is first and this is second and third and fourth and fifth and sixth. So this sixth one is metal and here the fifth one is oxygen, and here you can observe this R is above and this H is below. And here if you consider this third one, so the methyl is present top, that means axial position, and this H is in equatorial position, whereas the second one has R1. So this is actually Zimmermann effect. So simultaneous breaking of bond taking place. Now if you observe here, so see here, this position 1 and this is 2 and this is 3. Think about this 3 and this 1 and 2. Observe the positions of this R. So the first position and the second position, the alkyl group in the first position is in equatorial, okay, whereas the second position, so this methyl is in axial position, right? So that means this is axial and equatorial positions, right? So what happens generally in cyclic chair conformation? So 1, 2 equatorial and axial is always syn or cis, right? Okay, next consider this first and the third positions, first and third position. There is a diaxial interactions. Okay, consider the diaxial interactions between these two. So since it is hydrogen is small atom and alkyl is big atom, so there is less sterically hindered diaxial interactions you can observe, less sterical diaxial interactions you will observe, so that this is more favorable transition state. Okay, this gives you more stable product. Okay, so it gives the reaction sorry observe this OH and the methyl both are in syn position. So syn, which is major. So that means, which indicates that when the interaction of this alkyl aldehyde C and Re, okay, C and Re combination always gives you syn product is major whereas anti is minor. That means syn and anti has relationship is diastereomers. So one of the diastereomers is major, that is syn is the major one. Because what is the reason here? Because the 1,3-diaxyl interactions here have less sterical repulsions. That's why this transition state is more favorable towards the formation of syn product. Okay, this is all about the first one, that is acyryl aldehyde C and acyryl enolate recombination. And the second one, is acyryl aldehyde re and acyryl enolate recombination. So this is what the second one, which is like combination. Okay, like combination. So again, let us discuss about these both combinations. Take aldehyde, okay, and treat with the, this is Z-denolate, right? Z-denolate. Again, this is aldehyde. It has two phases, top phase and bottom phase. And enolate also having two phases, top phase and bottom phase. So this top phase is V phase and bottom phase is psi phase. Okay. Whereas in the case of enolate, so this sp2 is responsible for the formation of CC bond, so that here the top phase is 1, 2, 3, so psi phase, and bottom phase is V phase. So that means the interaction of this V phase of enolate with the top phase of aldehyde takes place here. Okay, what happens when this enolate approach to this aldehyde from the bottom phase? So these oxygens, two oxides, are having chelation with the metal, okay, which gives you a cyclic chair transition state. Cyclic chair transition state, that is called Zimmermann-Traxler, okay, transition state. Okay, Zimmermann-Traxler transition state. So let us think about that. So consider this is 1 and here one more oxygen, that is 5, and this is 6. This 5 has here, see, the R is this bottom and this one is an axial, and then in this position this is methyl is axial and H is here, and in this position R. So again, consider this first and second. So first and second, the alkyl is present in axial, and this methyl is present in the axial. So in cyclic, that means chair conformation, the 1,2 diaxial is always trans. That means it is anti. And here, if you observe 1,3 diaxial interactions, so there is, yes, more steric repulsions in this transition state. That is 1,3 diaxial interactions you can observe here, so that this is giving, that means, unfavorable transition state, which gives you a product which is trans. So this OH and CH3 are in anti-position. So it means when you have re and re combination, so you are getting anti product. But since it is unfavorable because of more sterical 1,3 diaxial interactions here, so that is the reason anti you will get. though you are getting anti here, but it is unfavorable always. So the first case, that is psi phase of achiral aldehyde and re phase of achiral Z enolate, is the preferred one. That gives you syn product is major. That means one of the diastereomer is major. Okay, this is second combination. In the next video, we are going to discuss about the other combinations, that is with the E enolate. That means psi phase of aldehyde and psi phase of enolate, and another combination is re phase of aldehyde and psi phase of E enolate. Okay. Thank you.